Hello, my amazing students. This is Mrs. A, and we are doing 6.1 homework help because we're getting close to our test and we need to get it all done. Okay, so we're going to start with problem number 5. It says in exercises 5 through 8, and we're going to be doing 5 and 7, refer to the continuous uniform distribution depicted in figure 6.2. Okay, so figure 6.2 looks to be this one right here. So this is the one that we're going to be looking at. And it says, assume that a passenger is randomly selected and find the probability that the waiting time is within the given range. So this one was greater than 3 minutes, and greater than 3 minutes on here would be this region that was bigger than 3 and bigger than 4. So basically you can draw a little line right here, okay? So that's 2 slots out of 1, 2, 3, 4, 5 slots. So 2/5 of this area, remember the area is 1, so 2/5 of that area would be 2/5 of 1, or 0.4. So we have the probability being 0.4 or 40% for that one. There wasn't much work to do for that one, so 40% for number 5. And when I look over here to number 5's answer, it is 0.4 or 40% of as the probability for number 4. For number 5 is 0.4. Then we're going to do number 7. It says between 2 and 3 minutes. So between 2 and 3 minutes would be just 1 slot of area here. Remember, this is uniform, so it's going all the way across. It was equal probabilities for the whole thing. So between 2 and 3 is 1 slot out of the 5 slots, so it's 1/5. And the 1 times the 0.2 is going to be 0.2, and 1/5 winds up being 0.2. So number 7 should be 0.2, and it is. So 20% or 0.2 is the probability of between 2 and 3, and that was number 7. Now we're moving on to number 9. And number 9 says, in exercises 9 through 12, and we're going to be doing 9 and 11, find the area of the shaded region. The graph depicts the standard normal distribution of bone density scores with a mean of 0 and a standard deviation of 1. So on number 9, we're supposed to find the area under the curve. Remember, the area under the curve is the same thing as the probability of the event to the left of 0.44. But we're just doing area of the curve. They would be the same. And we're going to say the z-score is 0.44, which means I can go to my z-score chart and look up 0.44 in the body of the chart. No, excuse me, 0.44 is the z-score. So we'll look it up in the edges of the chart. So that will give us the area to the left. So let's go to our z-score chart. Okay, so to find 0.44, I'm going to find 0.4 on the left, and I'm going to go across to 0.4, and I'm going to bring them down to meet each other. So here's the 0.4 row. I'm going to go across here right underneath the 0.4 column. So I'm going to get 0.6700. So 67% of is the probability to the left, and 0.67 is the area to the left. So the answer to number 9 should be 0.67. Okay, so when I go over here to number 9, I do get the area to the left of the curve is 0.6700, just like it said in the chart. So now we're going to go to number 11. These are pretty easy, aren't they? And we're looking for the area in between a z-score of negative 0.84, and a z-score of 1.28. So we're going in between, which remember, we'll find each z-score, we'll find the area for each one, and then we will subtract them, because the area on the chart is always in between. So negative 0.84 and 1.28. Let's go look at the chart. Okay, so I drew a little picture of what we were looking for, the area between those two z-scores. So now I'm going to go to my book on the negative side of the z-score chart. So here's the negative z-scores, and we're going to negative 0.8, which is down at the bottom. Remember, the negative score is a little bit backwards to what you're thinking. So negative 0.8 is way down here close to the bottom, and negative 0.84, so my 4 column is here. So I'm going to follow the 4 column down. I know this is a little blurry, trying to find the right distance here. So the negative 0.8 comes over, and the 0.4 goes down, and it looks like the correct value for negative 0.84 is 0.2005. And I really can't seem to bring that in focus, but that should be it, 0.2005. And now we're going to go over to the positive side and look up 1.28. So 1.2 is right there. We're going to go all the way across to the next to the last column. So we're going to follow the yellow row all the way across, 1.2, until we get to the 0.08 column, and we get 0.8997. Okay, so hopefully you're getting a better picture because you're doing it in your book. I can't seem to get it. 0.8997. Okay, so I have copied those two values of the area under the curve to the left of each one of those. So now I'm looking for the value in between. So I'm going to subtract those two values, and I should get a 0.6992. So let's look up the answer and see if it's 0.6992. All right, so here's my answer, and they give me two answers because they say the table answer is 0.6992, and the calculated answer on the calculator would be 0.6993. So basically, unless I tell you to use one or the other, I have to take both of them as correct. So unless you are told to use your calculator, if you're told to use your calculator, then use your calculator. If you're told to use the table, use the table. But if you're not told which one, then you're free to use whichever one, and I should be able to give you the correct, I should count it correct either way if I don't specify. All right, so now we're going to do 37 and 39, and to do that, we're using the bone density scores. So it says finding bone density scores here. In exercises 37 through 40, assume that a randomly selected subject is given a bone density test. So we're selecting one person. Bone density test scores are normally distributed with a mean of 0 and a standard deviation of 1. In each case, draw a graph and then find the bone density test score corresponding to the given information. Round results to 2 decimal places. Okay, so in 37, it says find P99, which is your 99th percentile. This is the bone density score separating the bottom 99% from the top 1%. So this is going to be far to the right of your area table. Okay, so here's our graph. We're looking for 99 percentile, and we're looking for the probability or the area to the left. Okay, so basically, if you look, I've got 0.01 right there on the right, and I've got 0.99 in the middle, and I'm looking for the area to the left of the curve would be 0.99. I don't have to think about that. Since they tell me that I'm trying to find the bone density score, and they also tell me that bone density scores are normally distributed with a mean of 0 and a standard deviation of 1, what I'm really wanting is the z-score. that's going with the 99th percentile. So we're going to go look up 0.999 in the body of the table. All right, so here I found it, 0.99, 99%, and 1% on the other side. So I think I said 0.999, but I really only wanted 0.99, so forgive me, please. So looking up 99% in the table, and that's going to go with 2.3, and when I go up, 2.33. 2.33 is the z-score that goes with the 99 percentile. Okay, so that was number 37, and coming over here, 2.33 is the answer for the 99th percentile z-score that goes with it. So now we're looking at number 39, and it says, if bone density scores in the bottom 2% and the top 2% are used as cutoff points for levels that are too low or too high, find the two readings that are cutoff values. Okay, so we're going to look for the 2% and on the top and 2% on the bottom. So let's go to the table here. Okay, I'm going to go with this one as being the closest to 2%. This one is farther away, and this one is 3 10,000ths away, and this one is only 2 10,000ths away. So I'm just going to go, I could go halfway in between them, but let's just guesstimate here. So we're just going to go to the left and up to see what that's going to be. So if I follow that little white line to the left, I get -2. And if I follow that little white line up, I get -2.05. So -2.05. Now, just think about this. Wouldn't it make sense that if I'm looking up 2% on the left and 2% on the right, that they will have the exact same z-score, except the left hand will be negative and the right hand will be positive. So before I even bother to look up 2% on the right, I'm going to think it's going to be positive 2.05. And as I go to the table, I'm not going to look up 0.02. I'm going to look up 0.98. Because remember, I'm looking up something that's got 0.202 on the right, not on the left. So my 0.02 on the right is going to be 0.98 on the left. 98% of my data will be on the left. And here we go. All right, I found my value. I'm looking for 0.98. This one is 2 10,000ths away. This one is 3 10,000ths away. So I'm going to go with this one, which is just 2 10,000ths shy of 98. So when I go to the left of that value along the yellow line, I get 2.0. And when I go back to that value and I go up, guess what I get? 2.05. So my two values, -2.05 and +2.05, would be the boundaries for the bone density scores that would be too low and too high. And again, those are the answers that they have in the book and the answers. The last one on this section is 41. So it says in exercises 41 through 44, find the indicated critical value, round results to 2 decimal places. So we have the z of 0.10. And remember, when we saw that value, when we saw this notation for the critical value, we had this little notation in the book. It says the expression z alpha denotes the z-score with an area of alpha to its right. Okay, so if we're looking up, as we are in our problem, z 0.10, we're looking for the critical value that has 10% to the right. that is going to be the same z-score that goes with 90% to the left. Okay, so I found 0.8997, which is as close to 90 percentile that I can get in the chart. You know, I could be more accurate if I went to the table, but let's see what our chart is giving us, our table. If I went to my calculator, I could get more accurate. So we're looking for 90%, which we've got 0.8997. If we go to the left, that's going to be 1.2. If we go back there and go up, we're going to get 0.08. So 1.28 should be the correct critical value. And 1.28 is the correct one as according to the book. And we are done with homework 6.1. That was not so bad. We'll move on to homework 6.2.